In this video, we will explore an important properties of rational function that are not present in the graph of In this video, we will explore an important properties of rational function that are not present in the graph of polynomial function, and this is about asymptotes. An asymptote is a line that a graph approaches a certain directions. A graph never crosses a vertical asymptote but may intersect a horizontal or oblique asymptote. So let's locate holes and vertical asymptotes. Holes and vertical asymptotes are both related to the zeros of the denominator of a rational function, but they behave differently. When you say zeros of denominator, so these are the x values that this denominator equal to 0. So like in this x minus 3, the zeros here is 3. In x minus 2 and x plus 1, now let us find a whole and or vertical asymptotes of the following. So the first function is x minus 1 squared divided by x minus 2 times x plus 1. Since we cannot see any common factor, so we can say that there is no whole. And then to locate for the vertical asymptote, so we have to equate the denominator to 0. So this denominator, when we equate to 0, so we can find the vertical asymptotes, which are x minus 2 times x plus 1 equate to 0. So when x minus 2 is equal to 0, we got x equal to 2. And then when x plus 1 is equal to 0, we got x equal to negative 1. So these two are the vertical asymptotes. And if you will graph this function in the Desmos, so you can find that the vertical asymptotes appeared in this vertical line, in this one, and there is no hole in the graph. Now for the second function, which is x minus 3 times x plus 3 divided by x minus 3. So let us find if there is a common factor, and we can see that there's a common factor of x minus 3. So the new function here will give us f of x equal to x plus 3, where x cannot be equal to 3 because we cancel out this x minus 3. So we can say, since there's a common factor, which is x minus 3, we can say that the whole appeared at x equal to 3. Or, since a whole is a point, which we will put an open point, so, or at point 3, comma, so to find for the y value of the point, so we will substitute this x equal to 3 in this function. So we will get the y value, which is equal to 6. So at point 3, 6. So next is, since the new function is a line with point of discontinuity at x equal to 3, and we cannot see any denominator here, so we can say that there is no vertical asymptote. And if you will graph this line with discontinuity at x equal to 3, so you can see that this is a line with a removable discontinuity at 3, 6. So this is the graph of this function. So the rational function becomes a line with point of discontinuity. So for the last example, when the function is x minus 3, or x minus 2, sorry, x minus 2 divided by x minus 2 times x plus 1, so we can see here that there's a common factor again, which is x minus 2. So the new function will now be equal to 1 divided by x plus 1, where x is not equal to 2 since we cancel out this x minus 2, and since there is a denominator of x plus 1, so we can also say that x cannot be equal to a minus 1. So this is now your new function. So we can say, Since there's a common factor of x minus 2, we can say that there's a hole at x equal to 2, or at point 2 comma, if you will substitute the x value in the function, the new function, so we will get the value of y, which is equal to 1 over 3. And then to locate for the vertical asymptotes, so since there is a denominator in the new function, which is x plus 1, so we will equate the denominator to 0 to get the vertical asymptote. So vertical asymptote is when x plus 1 is equal to 0, and we got x equal to the minus 1. And if you will graph this function in the Desmos, so you can see a rational function with vertical asymptote at x equal to -1 and with a hole at 2 comma 1/3. So looking back to these three functions, so you can see three cases. One is for the first function, we can see that there is no hole, but there are vertical asymptotes. For the second function, there is a hole, but no vertical asymptotes. And on the third function, there's a hole, and at the same time, there is vertical asymptotes. Now let us locate horizontal or oblique asymptote. When you say or, if there is horizontal asymptote, then there is no oblique. And if there is oblique asymptote, then there is no horizontal. So here, in locating for horizontal or oblique asymptotes, we will observe the degrees of the numerator and degrees of the denominator. So if the degree of the numerator is less than the degree of the denominator, then there is horizontal asymptote, which is y equal to 0. And when the degree of the numerator is equal with the degree of the denominator, then there is again horizontal asymptote, which is y equal to their leading coefficients. So for this first two, this has horizontal asymptotes. So let's have an example 1 on the first case. So we have a given function, and let us locate the leading term. The leading term for this numerator is -x, and the leading term of the denominator is 4x squared. So as you can see here, the degree of the numerator is less than the degree of the denominator. So we can say that there is horizontal asymptote, which is y equal to 0. And then for the second example, under the second case, so we have this function. So let us locate the leading term, which is 8x squared. And for the denominator, the leading term is -4x squared. You have to include the negative sign. So you can see from this that their degrees are equal. So we can write that degree of the numerator is equal with the degree of the denominator. And from this rule, if they are equal, so we can just take the leading coefficients of numerator and denominator, and that is the horizontal asymptote. So we can write that horizontal asymptote is y equal to the leading coefficient of numerator is 8, and the leading coefficient of denominator is -4. So we are writing 8 over -4, which is equal to -2. So that is the horizontal asymptote. Now for this third case, the degree of the numerator is greater than degree of the denominator. Then there is no horizontal asymptote, but there is an oblique or slant asymptote if the degree of numerator is 1 more than the degree of the denominator. So let's take a look at this example. So in this example, the leading term of the numerator is 2x cubed, and the leading term of the denominator is x squared. So as you can see here, the degree of the numerator is greater than degree of the denominator, and the difference of their degrees is only 1. So as you can see, the degree of numerator is 3 and degree of denominator is 2. The difference of their degrees is only 1. This is what we want here. So since this satisfies this case, then we can say that there is no horizontal asymptote, but there is an oblique asymptote. An oblique asymptote is y equal to, you can find the equation of this oblique or slant asymptote by dividing this numerator by that denominator. So you will use long division, which is 2x cubed, 2x cubed minus 4x dividing this denominator, it will give you a quotient which is 2x minus 2. So this quotient is your oblique asymptote. So y, which is equal to 2x minus 2, that is the oblique or slant asymptote for this function. So, as an important note, we can say that horizontal and oblique asymptotes cannot appear at the same time, as you can see in the three cases. Second, the whole and vertical asymptotes can appear at the same time. And the last, the graph of the rational function may intersect a horizontal or oblique asymptote, but never crosses a vertical asymptote. That is the end of this video. If you find this video useful, please like and subscribe and turn on the notification bell so you never miss out on the future content.